Alright guys, today we're going to start talking about powers of I, and more specifically the pattern that emerges when we start looking at that. This is going to be really important before we get into multiplying complex numbers, so we really need to make sure that we've got a good handle on this. Now, first we're going to start off by using some definitions, and then we're going to be using some properties that we have discussed previously in this class, specifically as they relate to how to go and do things with radicals. So first off, we're going to take a look at the powers of I pattern. So the first one that we have right over here is I to the first. Well, anything that's raised to the first is really just whatever the base is. So I to the first we know is really just I. Easy enough, right? The next one that we have is I squared. This is actually going to be the single most important one that we're going to go and discuss. And I could just tell you the answer, but I'm not going to, because I want to explain what all of this stuff means. So we need to remember that when we have an exponent of 2, it implies multiplication. It implies multiplication of the base exactly twice. So I squared is really the same thing as I times I. Okay? Well, what is I equivalent to? We should remember that I is the square root of negative 1. So this is really the square root of negative 1 times the square root of negative 1. Well, we could go and we could rewrite that as the square root of negative 1 squared, couldn't we? And then we have this inverse operation where we have this square root and we have this exponent of 2. Those are inverse operations of each other. And what does an inverse operation do? Well, it eliminates. Okay? So now we have the case where we no longer have a radical. So I squared equals negative 1. That is, hands down, the most important relationship that you are going to need to remember for the duration of this unit. I squared equals negative 1, and it's because of what I means, what it's equivalent to, and then what those operations with radicals imply. All right, so the next one we have is I cubed. Well, we could say that I cubed is the same thing as I times I times I, right? Well, these first two I's, I know what I times I is. I literally just did that in the last part of the pattern. What was I times I? Well, it's negative 1, but I still have one more I left over. And negative 1 times I is negative I. When I go and I take a look at I to the fourth, there's a lot of different ways that I could think about I to the fourth. One way that I'm going to choose to think about it is using that most important relationship that I have, okay, that I squared is negative 1. I to the fourth mathematically means I times I times I times I. Well, I times I is I squared, right? And then we're multiplying that by another I times I, which is another I squared. Well, what does I squared equal? Negative 1. What does the other I squared equal? Another negative 1. And what's negative 1 times negative 1? Positive 1. Okay? So the pattern that we're starting to notice from these problems is really, we have this I to the first is I. I squared is negative 1. I cubed is negative I. And I to the fourth is this positive 1. So this is that pattern, and I'm going to try and redraw that circle because that is just El Terrible right there. Okay, maybe I'll go and do a highlighter. That probably would be a better idea. So here's our kind of pattern that we've developed for these powers of I to the first is I squared is negative 1, I cubed is negative I, and I to the fourth is positive 1. One easy way that you can go and remember that pattern is simply to go look at it and repeat I1, I1, negatives in the middle. I1, I1, negatives in the middle. Okay? How does that pattern extend to other powers of I? Well, interestingly enough, if we go down here and we look at these other powers of I, okay, then what we're going to notice is that, well, we've got this I to the fifth. Well, what's a way using exponents that I could rewrite something that was the same thing as I raised to the fifth power? Well, I want to try and use I to the fourth as much as I can. Why would I want to try and use I to the fourth as much as I can? Well, what does I to the fourth equal? 1. And when you multiply anything by 1, it doesn't change. That's called the identity property. So if I look and I say, okay, I have this exponent of 5, okay? So how many groups of 4 fit in there? Well, 1. So this is I to the fourth. How many more do I need to get up to 5? Well, just one more I. So I to the first. Well, what's I to the fourth? 1. What's I to the first? I. So it's just I again. Okay? One of these days my eyes are going to stop looking like J's, but we'll get there eventually. So we said this was 1 times I, and that was equal to just I. So if we look at I to the 6, well, my exponent is 6. Well, how many 4s fit into 6? Well, again, just one of them. So I to the fourth. Okay, and how many more do I need, multiplicatively speaking, to go from an exponent of 4 to an exponent of 6? Well, I need 2 more. So I squared. Oh, so what's this going to be equal to? Well, I to the fourth again is, curious, 1. And I squared, we happen to know because we've got I squared memorized at this point, so that's negative 1. And 1 times negative 1 is negative 1. If I look at I to the seventh, I've got this exponent of 7, but I want to try and maybe break it down into as many 4s as possible. Why 4s? Because I to the fourth is 1, and I can use the identity property. So this is going to be I to the fourth. Well, how many more, multiplicatively speaking, do I have to get from 4 to 7? Well, 3 more. So I cubed. Well, I just so happen to know from my pattern that I cubed is negative 1 and I to the fourth is positive 1. So it's positive 1 multiplied by negative I. So what do I end up with? A negative I. Then I go and do I to the eighth. Well, how many groups of 4 are in 8? Well, 2. Okay, so I can write it as I to the fourth times I to the fourth, which is really just going to be 1 times 1, which is 1. And all of a sudden, magically, the same pattern that we found before is all of a sudden true again. Okay, I1, I1, negatives in the middle. It's going to repeat ad nauseum. Because if we look here, 5 is really 4 plus 1. Okay, 6 is really 4 plus 2. 7 is really 4 plus 3. 8 is really 4 plus 4. If I kept that pattern going and did I to the ninth, well, I to the ninth would be just I to the fourth times I to the fourth times I. So I'd end up right back just like I had for I to the fifth. So this pattern just keeps repeating over and over and over and over and over again. Okay, so how can we start to use this pattern to answer certain mathematical questions? All right, so that means that we're going to go over here and start taking a look at some of these problems. Okay, so the examples that we're going to take a look at to do this, and I'm going to give you guys a little bit of shortcut while we work our way through these as well. But we've got I to the seventh. Okay, so how do I go through and figure out what I to the seventh is? Well, it is already down on my pattern before, but just to show you, I would try and go through, if this doesn't do weird stuff, and look at this I to the seventh. There we go. Okay, so we got that I to the seventh, and I'm trying to think, how can I build to 7 using 4? Well, that would be I to the fourth, okay, and then how many more do I need to get to 7? Well, I cubed. okay? Because that's going to be equivalent to I to the fourth, which is 1. I cubed is negative I. Just one of those things we're going to go through and memorize. So it's the same thing as negative I. Now, we already found that by extending the pattern, okay? But what happens if I want to go and do something like the next example, which is I to the 14th? Do I really want to go and sit there and count and do like 1, 2, 3, 4, that's one group, 5, 6, 7, 8, that's the second group, 9, 10, 11, 12, that's a third group, 13, 14, so two more, so it's the same thing as I squared? Sure, you could go through and do that. You could literally count it out like this. And I'm going to try and show you guys how to just do the tapping method. So here's the tapping method. It works, it's tedious, but it's kind of nice for little ones. You ready for this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Because I ended here, it's going to be the same thing as negative 1. Okay, so I could go through and I could answer it that way. Never in a million years would I actually want to go through and do that, though. Okay, there's a much better way that we can go about doing that, and I'm going to show you that on example C and D. Because on example B, when we're counting to 14, it's pretty easy to count to 14. It doesn't take too long. But trying to do the tap method, counting all the way to 54, would take you like a week and a half to do. So there's another easier way that we can go and do this, okay? And it involves division and kind of using the ideas that we've already established here, all right? So the easier way that we can do it when we get these larger values like I to the 54th or I to the 121st is what you can do is you can take your exponent and you can divide it by 4. Okay, take your exponent, divide it by 4. Then what we're going to do is we're going to look at the remainder. Okay, all right, so our pattern was I 1, I 1 with negative values in the middle. Okay, if we take that exponent and divide it by 4, okay, if we take 1 and divide it by 4, we're going to get 0.25, okay? If we take 2 and divide it by 4, we're going to get 0.5. If we take 3 and we divide that by 4, we're going to get 0.75. And if we take 4 and divide it by 4, we're going to get a remainder of 0, meaning there actually isn't a remainder. So the shortcut way to go and apply this pattern for powers of I is really just to divide it by 4, because what that does is that tells us how many times the number 4 fits in. And then, because 25 is really the same thing as 1 out of 4, 0.5 is the same thing as 2 out of 4, 0.75 is the same thing as 3 out of 4, and a remainder of 0, 0 is the same thing as 4 out of 4, that kind of tells you that this one is going to be the same as I to the first. This one will be the same thing as I squared. This one will be the same thing as I cubed, and this one will be the same thing as I to the 4th. Okay, so that's kind of coming from whatever these little numerators are. 1, 1, 2, 2, 3, 3, 4, 4. So we can just go and divide the number by 4, look at whatever the remainder is, and that'll tell us where it fits in the pattern. Okay, so let's go take a look and see exactly how we can apply that to this problem. So if we've got I to the 54th, either in a calculator or if you want to do it in that big, beautiful brain of yours, you can do 54 and we can divide that by 4. Okay, so 54 divided by 4, well, that's going to give us 13.5. So it has a remainder of 0.5. Well, 0.5 is 2/4, so that's the same thing as I squared. And what does I squared equal? Let me try and make it better. There we go. I squared. And what does I squared equal? negative 1. Okay, if we do I to the 121st, simply take 121 divided by 4. So 121 divided by 4 should get you 30.25. Okay, so that 0.25 is a remainder of 1/4. So that's the same thing as I to the first, which is just I. Okay, so I realized I could have just told you what the pattern was and told you, oh, hey, yeah, just go through and divide by 4 and look at the remainder, and that's how you get the answer. But I really want you guys to start understanding the basic math that goes into all of this stuff and how it's not just this voodoo process where, oh, you just memorize what the answer is. Okay, so now I want you to go and, as you take a look at the assignment, see if you can apply what we've learned about the pattern to be able to answer all of those questions.
Now we're going to take a look at how we can use those powers of I to answer some more complicated problems, where maybe we have multiple terms instead of just one. So here we have the case where we have 3i to the 19th plus 2i minus 4i to the 10th plus 8i to the 16th. Our first step is going to be to simplify each one of these powers of I. So I'm going to do that dividing each one of them by the number 4. So if I take a look at the first one, which is I to the 19th, and divide that by 4, I get 4.75, which means that this is really the same thing as 3i cubed, okay? The second term is plus 2i. Well, I can't really simplify that anymore, so that's just going to still be plus 2i. Then I have minus 4, but what's I to the 10th? Well, 10 divided by 4 gives us 2.5. So that's the same thing as I squared, because 0.5 is the same thing as 2/4, so it's I squared, again following that pattern. Then over here at the end we have 8, and then 16 divided by 4 gives us a remainder of 0. So that's the same thing as I to the 4th. So what I've done for this is I've kind of gone and said, instead of, exponents of 19 and 10 and 16, let's make all of the exponents be either 1, 2, 3, or 4. Why would I do that? Because I know what I to the first, I squared, I cubed, and I to the 4th is. I know that I to the I cubed is the same thing as negative I. So this is really 3 times negative I. Okay? Then I have plus 2i. I squared is the same thing as negative 1. So that's 4 times negative 1. And I know that I to the 4th is really positive 1. So this is plus 8, but instead of I to the 4th, it's now 1. So simplifying each one of these, I have negative 3i plus 2i. Then it's going to be plus 4, and then plus 8. So combining all of my terms, I'm going to end up with negative I plus 12, okay? But I can't actually write it that way. I can't write it that way because it's not in standard form. Remember that standard form, okay, which is very important, so standard form is A plus BI. So the real number part always goes first, the imaginary always goes second. So I would need to take this particular answer and rewrite it so that it was 12, my real number component, minus I. And that, ladies and gentlemen, would be the simplified version of 3i to the 19th plus 2i minus 4i to the 10th plus 8i to the 16th.